In the last video, we saw how a program talks to the operating system using a system call. Now comes a very interesting question. When the CPU finishes executing operating system code, does it always go back to the same program? The answer is no. Sometimes it switches to a completely different process. And this is called context switching. Let's understand this with a simple example. Imagine process A is running on the CPU. Everything is going normally. Then process A tries to read a file from disk. Now disk operations are slow, so process A cannot continue immediately. At this point, the CPU switches into kernel mode and starts executing operating system code. It jumps to the part of the OS that handles this request. The OS sees that process A must wait for the disk, so it marks process A as blocked. Now, an important thing happens. The code that handles the disk does not directly switch to another process. Instead, once it realizes that process A cannot continue, control goes to another part of the OS called the scheduler. The scheduler checks which processes are ready to run. Let's say process B is ready. So instead of wasting CPU time, the scheduler decides to run process B. So now the CPU prepares to switch from process A to process B. Before switching, the CPU saves the current state of process A. This state includes things like the program counter and registers. When the CPU first entered kernel mode, this state was saved on the kernel stack. And when switching between processes, this state is stored by the operating system in memory associated with that process, which we earlier called the process control block, or PCB, which stores all this information about that process. When the program is running normally, it uses the user stack. But in kernel mode, it uses a separate kernel stack to save and manage this state. You can think of this like taking a snapshot of process A, so that it can resume later from exactly the same point. Now, the CPU loads the saved state of process B. This state was saved earlier when process B was paused, and the CPU starts executing process B. So while process A is waiting for disk, process B is using the CPU. Later, when the disk operation finishes, process A becomes ready again, and the CPU can switch back to process A and continue from exactly where it stopped. This is the core idea behind multitasking, how one CPU runs many programs. Now, here's the next important question. When does the CPU decide to switch like this? We'll explore that in the next video, so subscribe if you don't want to miss the next video in this series. I'll see you there.